Good afternoon, everyone, and welcome to Defending Against Deepfakes and Dark Patterns with AI. My name is Rita Arrigo, and I look after strategic engagement at the National AI Centre. And today we're welcoming you to this webinar where we're going to talk a little bit about deepfakes and dark patterns. First, I'd like to begin by acknowledging the Wurundjeri people of the Kulin Nation as the traditional owners of the land that I'm presenting from today, and I pay my respect to the elders past, present and emerging. So welcome to Defending Against Deepfakes with Dark Patterns with AI. Defending Against Deepfakes and Dark Patterns with AI. Today is one of many series of workshops that we've been holding and webinars around this topic, and it's part of the Responsible AI Network. I'd like to introduce the agenda and our speakers. Today we're going to be presenting on the cutting edge of the AI-powered science agency, Australia's National Science Agency is designing to prevent digital deception. You're going to hear from Dr. Kristen Moore, who's going to talk about the challenges of deepfakes and the ways that we're combating them. We're also going to hear from Dr. Jieshen, who will share details about dark patterns and will demonstrate ways to counter this deceptive behaviour online. Let me tell you a little bit about Kristen. She's a machine learning and cybersecurity researcher here at CSIRO and renowned for the cybersecurity honeypot known as deception as a service. And I'm going to tell you a little bit about that in a minute. And there's a range of hyper-believable documents to deceive bad actors. Her research interests are in the use of AI to augment cyber defense capability with a focus on cyber deception and generation of fake cyber artifacts. She's a finalist of the Women in AI Australia New Zealand Awards in Cybersecurity, and is the technical lead for the Cybersecurity Deception as a Service, and is currently leading the lead for advancing AI in cybersecurity. We actually met at Telstra, where she worked as a senior data scientist, leading a collaborative human AI customer support system that was used by over 1,000 Telstra customer support staff. Today, she will share her work in deepfakes, sharing the challenges and how we are combating them. Dr. Jieshen Chen is currently a research scientist at CSIRO Data 61. She received her PhD at ANU and works at the interaction of software engineering and human-computer interaction, where she uses human-centered techniques to examine and ensure responsible software development by design. She's currently working on the dark pattern detection, data visualization, UI design search, generation and mobile application accessibility enhancement, and she will share details of her work in countering the effects of dark patterns. I'd just like to introduce by sharing some data around a recent survey that was done about how Australians are the most nervous about AI of any country globally. And I think it's these kind of initiatives that we're sharing today that can really make a change to this. And not only that, we also know that there are so many advantages to organisations in deploying AI. This study was a study of Australia's ecosystem that shows the current focus of AI, which is very strong in the IT operations space and the network monitoring. And we see this new future that's emerging around knowledge management as the next big area. And it is the Responsible AI Network that we're here to help support, build this muscle around responsible AI through law, standards, design, leadership, principles, technology and governance. And you can review many of our Responsible AI Network workshops by going to the National AI Centre website, where you can watch the recordings ranging from introduction to standards for AI, introduction to responsible AI engineering, how responsible AI integrates large language models, how to responsibly integrate large language models into your business, as well as implementing responsible AI in business webinar, which was a great webinar that you can watch, which shares a lot of the details around implementing Australia's AI ethics principles. And most recently, we had a workshop with standards for responsible and inclusive AI. So I urge you to go and watch them if you haven't. We also have some great reports available on the National AI Centre, and one that really comes to mind is the Generative AI Opportunity, which was a report by Tech Council of Australia and Microsoft, and it kind of goes through all the different areas where generative AI is already co-piloting work. And just by way of introduction, before we move on to hear from Kristen, this is the story around the Data 61 cybersecurity honeypot, where it uses generative AI to create a honeypot, and it allows people to find those documents and to basically use that as the deceptive act. And this solution has a range of other ML generated deception tools, including social interactions, a code repository, knowledge bases, and different areas. And it's super exciting to have Kristen here to present on her initiatives in the deepfake space as well. And I'd finally like to just talk about another area of generative AI really supporting conversational AI by using, which is a solution that's been developed called Aparte, which is the god of deception, where you use conversations that have been fine-tuned with generative AI to combat scammers. And so it's super exciting to see these kind of initiatives being able to make a big difference to the way AI is being used in Australia. But now I'm going to hand over to Kristen to share a little bit around deep fakes. But I also like to urge you to add your questions. We also will have a survey in the chat for you to respond to, and look forward to hearing more from your questions. But now over to you, Kristen.
Thank you, Rita, and thanks to the National AI Centre for the opportunity to talk today. Let me get my slideshow working properly.
Beautiful.
Good. Okay. So yeah, my name is Kristen Moore. I'm in the Cybersecurity and Quantum Systems group at CSIRO's Data 61, and I'm going to tell you a bit about our group's work in the direction of deepfake detection. So I guess most people would be familiar with deepfakes on some level, but just to set the scene, a deepfake is content that's generated by an artificial intelligence that is authentic in the eyes of a human being. So the most common use of deepfake technology is to replace the identity of individuals in audio or visual media whilst trying to deceive the audience that it's real. And so just to give a very simplified view of the process in creating a deep fake, you might have a funny or an interesting photo or scene from a movie and a face you want to substitute into it. So you just put them into a neural network, and the neural network will change it to the identity of the substitute person's face and blend that back into the original image, just like in this example here with the Elon Musk baby. And if we look at the most common types of deepfake, we of course have images, and then there's videos, which most commonly focus on facial manipulations, of which the two most popular methods are face reenactment, which involves changing the facial expressions, movements, and speech of a person in a video to make it appear as though they were saying or doing things that they never actually did. And the other main one is called face swapping, where the face of a person in a video or image is replaced with someone else's face, making it appear as if the latter person was present in the original footage. We also have audio deepfakes, where voice synthesis technologies allow you to clone a person's voice and then create audio of them saying whatever you like. And lastly, there's the textual deepfakes, where thanks to modern, robust, large language models, AI can now compose writing with human-looking substance, creativity, and clarity. And so if we look at generative AI technologies used in deepfake creation and also in their detection, there are four main players. The first are autoencoders, which is a type of artificial neural network that consists of two components. It's got an encoder and a decoder. The encoder learns to encode input data into a lower dimensional representation, and then the decoder learns to decode it back to its original form. And so in deepfake creation, autoencoders are used to generate a compressed representation of, say, a person's face, which can then be used to manipulate and overlay onto another person's face, resulting in a realistic and convincing deepfake videos. The second main player in deepfake generation is called generative adversarial networks, known as GANs. GANs are very popular in deepfake creation, and they consist of two components. They have a generator and a discriminator network, which are trained simultaneously in a two-player adversarial game. And so the generator aims to fool the discriminator by generating samples that are indistinguishable from the real ones. Next up, we have diffusion models, and they aim to model the process of randomly spreading or diffusing information through sequential transformations. So in deepfake creation, diffusion models can be used to generate realistic and high quality images by iteratively applying diffusion processes to an initial image and gradually refining it. And these diffusion models are becoming very popular for deepfakes due to their ability to generate high quality and realistic outputs with fine-grained control and improved training stability. And then lastly, we have transformers, and they're famous for their success in natural language processing, but these can be used in deepfake applications for text or video or audio, and also for applications like text-to-image synthesis. And so while there are many entertaining memes on the internet created by deepfake technology and a range of other positive uses for deepfake technology that people can enjoy, it's also very important for people to understand the concerns. And the problem is that when put to malicious use, impersonation and the falsification of media is dangerous. And without awareness of what deepfakes can do, they can easily spread misinformation and cause a lot of damage. And unfortunately, it's very easy for a criminal to download a high quality deepfake generation tool for free from GitHub and start using it right away. So as technology companies and researchers compete to produce better generative AI models, such as diffusion models, the threat of deepfakes is only expected to increase. And so to highlight a few of the biggest threats on this slide, according to the NSA, synthetic media threats that organizations most often encounter include activities that undermine the brand, the financial position, the security, or the integrity of the organization itself. And the most significant threats based on their potential impact and risk to the organization include firstly, employing convincing audio and video impersonations of key leaders to damage the reputation and value of an organization's brand. For example, distributing a deepfake publicly across social media before it can be stopped or disputed. Such operations have targeted high-profile political figures in the past, such as Ukraine's President Zelensky, to spread disinformation and confusion. The second one is impersonation for financial gain. So these are generally social engineering campaigns, which again may include impersonating key leaders or financial officers, but in order to illegitimately authorize the disbursement of funds to accounts belonging to the malicious actor. And the third example is impersonation to gain access, and that access may be to an organization's personnel, their operations, or their information. So for example, a big one during COVID was the use of manipulated media during job interviews, especially for remote jobs. Another example is if you imagine an employee, say in the critical infrastructure sector, receives a call from their administrator asking them to perform some task, like change some settings or something. This could be a deepfake where the attacker has cloned the administrator's voice and are using it to take over the facility. And I also wanted to give some examples of how members of the general public can fall victim to deepfake attacks. And this can occur in various cybersecurity applications like account authentication. So live identity verification services are vulnerable to this, since deepfakes can now be generated in real time, enabling attackers to impersonate people over audio and video calls. So specifically, the first example here I've got is facial recognition and verification APIs. There are several companies, including Microsoft and Amazon, who provide highly accurate commercial face recognition web services. And this technology is used in a number of sectors. There are several banks around the world that have implemented facial recognition technology as part of their security and authentication systems. And as another example, for many years, Uber have been checking that a driver's face matches with what the company has on file through a real-time ID check. And this aims to prevent fraud and protect the driver's accounts from being compromised. And in our group, Shiraz Tariq led a first of its kind measurement study together with international collaborators from South Korea to evaluate the robustness of such face recognition and verification APIs under deepfake impersonation attacks. So they tested 6 popular commercial as well as open source face recognition and authentication systems. And in their experimental settings, the deepfake targeted attacks had a very high success rate, demonstrating that this facial recognition technology is indeed vulnerable to deepfake impersonation attacks. However, in their paper, they also propose a defense mechanism to mitigate these attacks effectively. And they demonstrated that their defense can lower the targeted deepfake attack success rate to very low as around, as low as around 1% in some cases. So this work was published in the ACM Web Conference in 2022 for anyone that's interested. And the second example that I wanted to highlight here is the voice authentication APIs. Because when you call, say, Centrelink or some other government services these days, you're prompted to set up your voice print, which will then be used to prove your identity when you call. So when you call Centrelink and use voice print, you don't need to say your PIN or you don't need to answer the security questions. However, deepfake voice clone technology does present a security risk to these voice authentication APIs. Okay, and so how about the human natural ability to detect deepfakes? There are numerous studies aimed at trying to determine how well ordinary people can tell the difference between a video manipulated by AI and a normal, non-altered video. Results indicate that people are concerned about deepfakes. I think that aligns with what Rita was saying at the start. And there is an increased awareness of them amongst the population. But studies show that while people are aware of the deepfakes, their ability to distinguish them remains low. So for the question of whether we can trust our senses on this one, the answer is probably not. Research shows that humans suffer both false positives and false negatives when attempting to discern. And so another problem is that people, despite not being able to detect the deepfakes, they think they can. So they might be overly confident as well. So that's not to say that you can't train yourself to be good at detecting them, because that is certainly possible. But rather, without that specific training, the quality of deepfakes these days makes them very hard to discern. Okay, so it's clear that humans struggle to detect deepfakes on their own. And as deepfake technology continues to advance, it's becoming increasingly important to develop a more comprehensive detection frameworks. And people are working tirelessly on this problem. And so just to give a bit of an idea of what that looks like, if we look at deepfake video detection, approaches of these AI-based detectors roughly fall into 2 categories. We've got artifact-based detectors. And so the idea is that deepfake generation tools introduce certain artifacts into the deepfake, which, though being subtle to humans, they can be detected by neural networks. So there are many detectors in the literature that take a feature extraction-based approach and try to identify particular spatial and temporal artifacts that are introduced by the deepfake generation tool, akin to a detective looking for, clues and fingerprints at a crime scene. So, for example, in images and videos, some artifacts appear where the generated content is blended back into the frame. Other artifacts might be related to the environment or forensics, for example, lighting or shadows being inconsistent. And there are also temporal artifacts, like the synchronization or coherence across frames might not be very good. And so then the second category of deepfake detection includes black box type approaches. And so these are sort of trained like anomaly detectors or classification approaches, but they're not designed to look for particular features, let's say. And so deepfake detection is very challenging, and because it's an arms race between attackers and defenders. So as a new deepfake generation tool is released, then a new detector is released to combat it. But as those detection methods are developed and made public, there is often a quick response from the generation community to counter them. And other challenges in this problem is that these detectors typically don't generalize well to unseen attacks. So they might not perform well on new deepfake generators. And they also don't generalize well to new distributions. And this is why deepfake samples from the wild are always more challenging than those in like the training data sets. And that's because research data sets are usually generated in a lab setting, which is a lot less diverse than in the real world. Okay, so I just want to highlight a few select works from our group members in these two particular directions that we're interested in. The first direction is understanding deepfakes in the wild. And so together with an international partner lab from South Korea, we've recently collected a data set of 2,000 videos found in the wild on platforms including YouTube, TikTok, Reddit, and Bilibili. We've analysed the data set to understand the patterns and evolution of deepfakes over recent years. And we also developed this data set as a vital resource for evaluating the robustness and generalizability of deepfake detectors. And so this work will be presented at the ACM International Conference on Information and Knowledge Management in the UK next month. Secondly, in this direction, our team member, Shiraz Tariq, has also worked on developing detectors that are effective on deepfakes in the wild. That you can read about that in a workshop paper from Multimedia Privacy and Security. And then the other direction that we're interested in is the development of general deepfake detection framework that works on a wide variety of deepfakes. And again, Shiraz led a project on that where he developed one detector to rule them all, is what he called it. And this was published in the web conference in 2021. And additionally, in this direction, as deepfake audio technology continues to advance, including recent voice clones, it's becoming increasingly important to develop a more comprehensive framework for assessing the quality and reliability of deepfake detection methods. And we're currently working on this direction. Some other recent work we've done in this direction is to explore the limitations of current deepfake detection methods. And this work was, again, done in collaboration between our group and an international partner in South Korea. And in this work, we wanted to understand the challenges that deepfake detectors face when they're deployed in real-world scenarios. So scientists developing these deepfake detection methods, they often package them up into off-the-shelf detection tools so that they can be used by people in industry or government and research. However, a newcomer to the field of deepfake detection may deploy such a tool only to find that its performance in their real-world setting may be significantly lower than the accuracy that the creators of the model reported it to have. And in our paper, we demonstrate how certain deployment settings can compromise the performance of such deepfake detectors. And we investigated 2 specific scenarios where using deepfake detectors may lead to unexpected results. The first is the input data pre-processing. So this can happen when you have a mismatch between the pre-processing pipeline that was used during training of the deepfake detector and the one that's used when you go and deploy it in your real-world application. And the second direction where they can cause problems is the diversity of the data used in training. So a lack of diversity in the data sets used in training can lead to biased and unreliable results. And so you may find that you get worse than expected performance when you deploy it in a context where your data is like sort of a new unseen data distribution to the deepfake detector model. Okay, and so I realize I'm running out of time, so I'll just run quickly through the last bit. I have some suggestions around how we can protect ourselves. So there's the first one is to ensure that your employees and family understand how deepfakes work as much as possible and the challenges that they pose. And if you can, it would, it's good to educate yourself and others on how to spot a deepfake. Another one is to have good basic protocols. So they call it trust but verify. So for example, if someone asks you to do something, significant, like transfer money or something like that, you can, if they, call you to ask you to do that, you can then go and confirm it on a different channel, say on Slack or email or something else, just to validate that, yeah, it's not some deepfake attack that's been happening. The next one is security. So if you maintain good security hygiene, so having different strong passwords for different accounts means that if one network or service has been broken into, that it doesn't mean that the rest of them will all be compromised. And so yeah, another one is make sure you're media literate and use good quality news sources, so you'll be less exposed to deepfakes that way. And lastly, be careful about what information you're sharing and if it can be used against you. So for example, on your social media accounts, be conscious of your privacy settings and how much sort of media with your about yourself you're sharing to the public. And for organizations to protect themselves, 2 weeks ago, the National Security Agency and the US federal agency partners, FBI and CSIRO, issued new advice. They released the joint cybersecurity information sheet called Contextualizing Deepfake Threats to Organizations, to help organizations identify, defend against, and respond to deepfake threats. So this is like a 20-page or so document that it gives you tips on how to identify threats, which I've written some down here, and then minimize the impact of deepfakes, like ensuring plans are in place among organizational security teams to respond to a variety of deepfake deepfake techniques. And every organization should incorporate an overview of deepfake techniques into their training program. All right, last slide. Yep, is my future directions. So these are the directions that I think are going to be important looking forward. So human and AI collaboration. We need to work together on the task for deepfake detection. Explainable AI. So for example, if your detector provides visualizations of the artifacts that it thinks are indicative of it being a deepfake and presents them to the human in a way they can understand, for them to then make the decision. This prevents a much stronger detection system. Another one, next up is the ideal future where there's a universal adoption of authentication standards. So such authentication methods are designed to be embedded at the time of creation or time of edit of media to bring transparency to the provenance of the media. So an example of this could be digital watermarking, which can be used in synthetically generated media. And so there are initiatives working on this. The Content Authenticity Initiative was developed to push for provenance of digital content, and there are others like Project Origin. And further development in the direction of authentication and governance, yes, will help sort of take the pressure off these AI detection models. And then lastly, something cool that's come out this year is that existing deepfake defenses perform passive analysis to detect fake content. However, an interesting active defense approach has been developed by the research lab led by Israel Mesky at Ben-Gurion University in Israel. And inspired by the common capture tests, completely automated public Turing tests to tell computers and humans apart, like the one on this picture that no doubt everyone is familiar with, they've developed deepfake capture challenges, which challenge the deepfake model to generate content which exceeds its capabilities so that the content generated by the deepfake will be distorted. And this makes it easier for the passive detection models. Okay, and that's my last slide. Thank you. This is my team, Shiraz Tariq, myself, Sharif Abu-Adba, and we work with the lab of Associate Assistant Professor Simon Wu at SKKU in South Korea. And thanks to him and all of his students in that lab. And for those in industry or research that are interested to explore collaborations, please feel free to reach out to me. Thank you.
Kristen, that was amazing. Thank you very much. And I like these hints you're leaving here about spotting deep fakes.
Yeah, that was if a question came up.
There are some
Rita.
questions, but we are going to leave them till the end because we're going to ask Jieshen to share her content around dark patterns, and then we've got some questions. They're already coming through the chat. Thank you for everyone who's adding them. Over to you, Jieshen.
Thank you for having me today. So can you see my slides?
Beautiful.
Hello, everyone. Thank you for joining this webinar tonight. And also thank you to National AI Center to have me today. So today I will present our latest work on the on detecting dark patterns in the mobile applications. So my name is Jieshen Chen. I'm currently a research scientist at SE for AI team at Data 61. So this is a recent work that accepted by a top-tier conference with 2023. So some of you may not be familiar with the dark pattern this term. Just a second. However, dark pattern is actually everywhere in our daily life. So let me just first give some example. So they are quite prevalent in the home IoT device, such as the Apple TV, the Amazon Smart Plug, and they are also quite popular in the video platform where you're watching the video. And they are more prevalent in the mobile application that we use in our daily life. So let's see for the first example, which is a pop-up advertisement that will suddenly pop up while you're doing something with the mobile application. And it is quite annoying, and it will keep popping up no matter what you are doing. And then you cannot dismiss them forever. They will still coming. And another example is the notification. This kind of notification is enabled by default. You must have received many emails about the product updates, some new follower from the LinkedIn, and you didn't agree to subscribe to those newsletters by yourself, but they just coming to you because they are already enabled by default. And the last example will cause some financial loss to you. For example, while you're using the mobile application, they may require some subscription. And the good thing is that they do provide some free trials so that you can use their application without paying to them. However, what you may know that maybe after some time, you try the application and you find it is not what you want and you stop using that. However, maybe some days after that, you suddenly find that some money is deducted from your account. That is a kind of dark pattern called false continuity. It will automatically subscribe you to the application, although you did not consent to that. And let's officially define what is dark pattern. There's some problem with this face story. So let's officially define what is dark patterns. So a dark pattern is defined as a user interface that maliciously crafts to deceive user into performing action they did not mean to do. So according to the research, there are 95% of mobile application contains on average about 7 dark patterns in their mobile applications, and over 11.1% of the shopping website also contains sort of dark pattern. They are quite prevalent in those mobile application, shopping website, video streaming platform, so just all the things you will use nowadays. So the existing of those dark patterns will make customer or user or you unhappy, and you will cause you to lose the digital trust in the business, or you will cause some financial loss. So the legislation starts noticing this behavior and then start publish some guidelines to constrain the uses of dark patterns. So we as a normal user, how can we defend or avoid ourselves being tricked by the dark pattern? So there are many existing words that try to help you in these cases. For example, there are many researchers, some academics, that they try to summarize a taxonomy of dark pattern to help you understand the overview of the kinds of dark pattern in the world around you. However, the negative side of this kind of technology is that it requires you to read through all the papers, and you need to read them carefully and learn it by yourself. Another method is more easier to access. That is, some people use some crowdsourcing technique. For example, they build a account on the Twitter called Dark Patterns, and also some channels in Reddit called Asshole Design that allow the end user to update the new dark pattern they meet in their daily lives. So if you subscribe or follow them, you can see what kind of dark patterns are emerging nowadays, and you can raise your awareness on that so that you can sort of protect yourself. And similarly, this kind of techniques also has the same problem as the taxonomy one, because you need to follow these news posts by yourself and try to keep update. And the last one is that some academics think, so why not we just remove those dark patterns from people's lives, so they will have no trouble to learn the new knowledge or to be cautioned all the time. So some do provide some developer patch or user patch to modify the source code of the application, and then the end user can use the modified version in their mobile phone so that they can block the area of the dark pattern. However, one issue is that this kind of developer patches or the user patches require a great expertise in programming background or also the knowledge on the dark pattern. On the other side, because the application is modified, it will also incur some additional privacy issues, which means the virus may be embedded during this process. So given nowadays the AI techniques is quite advanced, so we are thinking, why not we can provide some lightweight method to help user to identify, highlight the potential issue, and raise their awareness on dark pattern during their uses of mobile application. So we propose a technique that incorporating the pattern matching technique and also the computer vision technique to try to highlight the potential issue while people using their application. And this kind of method is automatic, so you will relieve the burden of people to manually identify it. We also develop a database so that people can also read through all the data set and understand more about the taxonomy, the effects, and the impact. So as a start, we first utilize the existing taxonomy as our knowledge base. So we mainly focus on 5 primary categories: nagging, sneaking, interface interference, and so on. And here shows the definition of those taxonomy, those categories. And behind those categories, there are around 27 more detailed cases. So we conduct a characteristic analysis on these cases and understand what is the key attribute we need to focus on and how can we detect them automatically. So therefore, we propose our technique we called UI guard. And so the input of it is just a UI screenshot, and we will extract the key attribute in the user interface, and then utilize the knowledge we distill from the taxonomy. We conduct a dark pattern checker, and then identify the problems within this UI. So while we propose a technique, the must thing to do is to evaluate whether it is actually accurate, useful to the end users. Therefore, we conduct some experiment. So basically, we collected and manually label around over 6,000 user interface. And it turns out our UI guard can actually perform very well in identify whether a UI contains a dark patterns or not. And in terms of the details type of dark pattern, it also has a great performance. And we then conduct a user study to verify the true usefulness of the tool. So we involve around 58 participants from various backgrounds. As you can see on the bottom right, there's the distribution of the background. And so what we do in this user study is that we first present these participants on user interface and ask them to maybe try to find some dark pattern they see in this user interface. So after that, we present the detection result of our tool to try to maybe educate them or help them to understand the dark pattern. And after that, we present another set of a similar user interface to see if there is any increase of their knowledge on dark pattern. And the result is quite prospective. The record rate increasing from 18% to 57%. And most of the participants are really appreciate our tool, and they give a rating of usefulness at 4 or 5. So let's envision some potential uses of our tool. So the first one is definitely that for the end users. So maybe while the user using the mobile application, we can help them to highlight the potential issues and provide maybe some question mark hint, and people can click on it and see what kind of dark pattern it is. So gradually, if they are already familiar with certain types of dark pattern, we can disable the highlight for those dark pattern and leave the one they are not quite familiar with. And the second one is for the app provider. Although they are the one who designed the dark patterns, we are still want to help them to maybe help them to understand the UI user interface they design is actually very bad, and also add some legislation rules to that to let them know the impact of it and maybe the consequence of implementing a dark patterns. And the last one is for the regulators. You know, there are so many millions of thousands of mobile applications nowadays, and those applications keep updated. So it is very hard for the regulators, including the legislator and also the app market, to constrain the problems in the mobile applications. So we are thinking maybe using our technique, we can help them to automatically generate a dark pattern report that can alleviate their burdens on the examination, and also to help them to better implement their policies. So finally, here is the demos of our tool.
This is our UI Guard Android app. Let's first open YouTube application. This is the main page of YouTube. We activate our UI guard by clicking on the Android icon. It turns out that the upper part of UI is a disguised advertisement, which pretends to be a normal content. We then open the notification page and activate our UI guard again. It turns out the whole page is all dark pattern, called pre-selection, which means that the notification is selected by default. This is up.
Okay, so that is end of my presentation today. So thank you for your time. And if you want to communicate with some further potential collaboration or other matters, you can always send me an emails. And the QR code here is the link to these papers. And one more thing is that our group is currently hiring some postdocs. So please feel free to scan this QR code to see the detailed application information. Thank you.
Amazing, Jieshen. That was amazing to see the kind of work you're doing in that space. So I'm actually going to ask you a question first. And the question is from Roy. And he asks, what happens when dark patterns become adopted across industry because industry typically tries to keep up with trends which make it more competitive, regardless of users' opinions?
Actually, for industry themselves, adopting dark pattern would be beneficial for them to gain more benefits from the end users. But the bad side is that, as I stated at the beginning of my presentation today, so the regulations, for example, the European Data Protection Board, are now focused on constraining the uses of dark patterns. So which means that they may get fired, they may be paid for their behavior if they keep adopting dark patterns. Yeah.
Thank you. I've got a few questions for you, Kristen. And the first one is, are these similar to the technologies that are used for silly face features on Instagram and Snapchat?
Yeah, it's the same general tools being used for the entertainment stuff and for the malicious stuff. Yeah.
Okay. And I've got another one. Can a high quality deepfake be generated on a local machine, or do you need to leverage cloud GPU and computing?
Yeah, look, it is possible to create deepfakes on a local machine, and there are even like mobile phone apps to create them. But leveraging cloud-based GPUs can significantly speed up the process. And I would say that it's essential if you're wanting to do like real-time, high-quality deepfake generation.
So Justin, who asked that question, thank you for that question, has gone one step further and he's saying, well, what could cloud computing providers do to help defend against this proliferation of deepfakes?
Yeah, it's a tricky one. One thing could be to enforce usage policies and monitor for misuse of their services to generate malicious deepfakes. What that would look like, I'm not sure. Potentially, like researchers would have to have some registration process to, validate that they're doing legitimate work for good. But in any case, to achieve, let's say, the monitoring and enforcing of usage policies, they can collaborate with cyber authorities and organizations in tracking and combating the harmful use of deepfakes. And another thing that's important is to enhance security measures to protect user data and prevent it from being used to create deepfakes. And so for this, they can offer like robust security measures, including encryption and multi-factor authentication and threat detection systems, just to make sure that, data being stored on their servers is secure and not going to be stolen and used for deepfake creation.
Wow, that was an excellent answer. And I thought this one was kind of from Graham, and he's asking, can the source of a deep fake be tracked?
Yeah, this is something that we've been exploring, whether deepfake campaigns can be traced back to certain groups or certain regions, and whether we can like fingerprint which generation tool was used to create, certain media. What I can say is that it's not easy. It's not an easy problem. Yeah.
Okay. I've got another one about what are the risks associated with these few powerful organisations, like you mentioned CAI and the C2PA, being the only sources of context and truth. Are there any open source alternatives being worked on, like an AI assistant able to assess the legitimacy of material? Sounds like a good idea.
Yeah, there are lots of tools out there. I think what these organizations can do is, I guess, come up with ways that we can sort of digitally fingerprint and track, like trace, media as it's created and edited, and sort of like a ledger, let's say. So they can come up with best practices and try to understand, work together to think up solutions to what's a very difficult problem. But definitely, like, a lot of the tools that are being created to detect material are available out there on the internet. Like, people release these tools so that they can be used by everybody. Yeah.
Okay. I've got another question for you, Jieshen. It's can UI Guard be further adopted to combat other malicious behaviour detection patterns like phishing detection?
Yeah, I think this is quite promising because the underlying technology are almost the same. For example, we need to understand the user interface, to understand the intent, and then we apply some rule to classify whether it is, for example, it is a malicious behavior or not. So I think I would say it could be further adopted to the other new types of behavior patterns. And also, as we know, the ChatGPT is quite popular nowadays. So given the new capability brought by the large language model, I think it would be quite promising and it's quite feasible actually. Yeah.
Oh, excellent. Thank you so much. I've got another question for you, Kristen, from Tim. And the question is, do you potentially see a future where there is low or zero trust in video or images shared over the internet? Do you think that large organisations will collaborate in time to maintain trust through these things, like CAI or C2PA that you mentioned? A scary future, but
Yeah. Like, unfortunately, I do think that we have somewhat crossed over to a point where it's very hard to tell if media is human generated or not now. So anything, say, before 2022, maybe you've got, like, that's a clean data set of human generated content, but going forward, it's very difficult. So yeah, that will definitely undermine people's trust, I guess. Yeah, and like, I can only hope that these organizations can collaborate to work on how we can maintain trust.
okay, I've got another one from David. There's a lot of questions coming through. So this is for you, and we've got the last few minutes of the webinar. So who should be responsible for fact-checking deepfakes? Should social media platforms or mainstream media be responsible in the same way that they might be for defamation, and the same way that misinformation warnings have with varying success been used?
I would imagine that mainstream media are definitely trying, and I'm not sure to what degree social media platforms are. Like, I'm sure they have teams that do it, and what their policies are around, their decisions around what, they share once they know whether or not things are deep fake. I don't know, but I think it's probably being done to a degree. And yeah, there needs to be legislation, I guess, around this to keep everything in check.
All right, I think this is one of the last ones. Are individual consumers more exposed to the risk of deep fakes, or is it business, assuming organizations have controls and firewalls? So is it people or business that are the biggest risk, and where is the biggest education needed?
Yeah, so the business ones are obviously high stake. Like, if you think of critical infrastructure, that's going to have a huge impact if you can, take over some critical infrastructure of a country, or if you can get, large amounts of money transferred to yourself. So you can see that those would be enticing targets for malicious actors. So I think, like, whilst everyone should educate themselves, obviously, like, the organizations have a lot to lose.
Yeah, so there's higher stakes for organizations than consumers, but it's probably the consumer's data that's going to be messed with. All right, I've got a question for you, Jieshen. It is, what can people do right now to avoid dark patterns?
I would say the first is to, first of all, the key always works is that you arise your awareness on the dark pattern knowledge. And the second thing is that I think people may want to participate on exposing those dark patterns, name and shame the company that use the dark pattern. That will eventually help the registrator to publish some regulation on that. That's actually what happened before. So there are only a little bit little regulation before. After some researchers or the people who start working on dark pattern, working on the taxonomy to understand the scale of the dark patterns. After that, the European Data Protection Order or Protection Board start focus on the problem, and then they publish some regulation. Then the constraint comes, and which can finally help to eliminate those dark patterns.
Okay, so there's a bit of work to be done around that. We've come up to the last few minutes of the webinar. I'd like to remind you that there is a survey in the chat, and we'd love your opinion around today's content. I'd also like you to join our Responsible AI Network, connect with Australia's AI industry at the National AI Centre website, join the conversation, and I'd like to thank our speakers for their excellent content. Thank you so much, Kristen and Jieshen. It was such a fantastic discussion to kind of, really dig deep and find out more about that. And thank you again for being such a great audience and for all your questions. I'm going to